Good morning, class. I am going to walk us through. Oh, hang on. Okay, we're going to go through this worksheet. We're going to talk about the number E, which is really what we get to when instead of compounded interest come annually, semi-annually, monthly, or anything of that, we really get down to continuously. So I might be skipping around a little bit in this worksheet, but can't hurt to do a few of these. So we have this example which looked pretty normal for a $650,000 house, which I picked because it was the 2020 median price in LA. We made that interest rate 3%, and a home loan is typically 30 years. So we tried to figure out, okay, well, basically, if I were to pay this all off at the end, 30 years from now, how much would it be? So it is a matter of just plugging into the calculator, but watching people do that yesterday definitely could use some sharpening of those skills. So my advice is when in doubt, use parentheses. I'm going to type it into this scientific calculator first, and we can do some of the later ones on the graphing calculator. So 650,000 times 1 plus, and I'm going to put this in parentheses, even though I realize I'm dividing by 1 in my first example, but just so that we kind of get the idea here. 0.03 for that 3% divided by 1, end those parentheses, to the power of, and that is this button right down here, to the power of, and again, I'm going to use parentheses for doing 30 times 1, 30 my number of years, 1 being my number of times per year that I compound. And I get this number right here, which we can copy down and put. All right, so that it looks like a 1,577,720. Okay, quite a lot considering it was originally a $650,000 loan. If I change that to semi-annually, the beauty of what I did and the way I did it is I just press the up button and it allows me to edit this equation. So I'm just going to go to where it says 1, which was the k, the number of times. It appeared twice in this equation. And so there we go. And now we get this $1,588,092. And I am rounded, of course. Here I took off the cents. Let's just do one more of these, realizing that, of course, these numbers are going up. So again, I'm just going to hit the up button, which brings me back into it. I'm going to replace that 2 now, and I have to be careful here. Do a second insert to replace that 2 with a 12. And again, second insert, 12. If I don't do the insert button, it'll just overwrite the 2, and I'll lose a lot of stuff. All right, and this time we are at 1,596,596, yes, 947. Obviously, if we did it weekly, that's going to be more. Daily is going to be more. Hourly is going to be more. Secondly is going to be more. You know, if you want to put in secondly or minutely or something like that. Continuously is going to be more, but it doesn't go crazy. We do reach a limit. And I wanted to show you that. as we do the same thing again, really, except we are just using both P, R, and T, all P, R, and T as 1, and just increasing K to kind of see what this looks like. So again, I'm just going to start over on this one. P is 1. I really don't need to put it in, but there it is anyway. Times 1 plus, and in parentheses, 1 divided by, in the first case, it's going to be 1. End of those parentheses, both of them, and bring this to the power of, in parentheses, they wanted time to be 1, and 1 times 1. Okay, and enter. And in this particular case, I get 2. If I hit the up arrow, I can replace both those K values with a 10. So a second insert there, got a 10, and make this one, I'm not going to do the insert, I'm just going to replace it and put in a new parentheses. I don't know if that's altogether visible, and hit enter. And now I get this 2.59 business. 2.59. And I can keep on going. I'm going to skip 100. I'll go to 1,000. So up and change that 10 to a second insert. 1,000 and make sure that, yep, kept all those. And change this to a 1,000. I know it's hard to see on the thing. And hit enter. And this time I get a 2.717-ish. 2.717. Well, at the bottom here, what I did was I drew a graph as, and you can see that there is a pretty large scale here. I'm going to pause and we've got to. Okay, so hang on. Okay, so as K gets bigger, the value that we arrive at here gets really, really close to this number, which we call E. There's not a whole lot you have to know about E. Here's a real formal definition. That triple equal sign there, it's not a typo, that just means it's defined as the limit when K goes to positive infinity. So you're really close when you get K equals 1,000. You're even closer when you get K equals 1,000,000. You never get actually 100% there because E, much like pi, is one of those irrational numbers which goes on and on and on forever. If you want to see an approximation for E, you can go to, let's see, where is it on this calculator? Right there. So I'm going to turn it back on, clear, and go to second E to the power of. That comes automatically when you type in that E button. It's so used to being taken to a power. Well, if I just take it to the first power, it should tell me what E is. And E is about that 2.718-ish. Okay. How are we going to use it? We are going to use it in all kinds of different questions. Obviously, the money thing that we've been dealing with, banks actually do use this. This is how they do it. They don't compound annually or semi-annually or anything like that. It is continuous. We will use it for studying population growths and really anything that we consider to be growing continuously. Computer storage is a fun example I always like to look at. There's a problem I put towards the end where I talk about the 1.44 megabyte computer disks that we used to carry with us everywhere we went. In fact, the save icon is still a floppy disk. Those haven't been used forever. Those got replaced with CDs, which got replaced with DVDs, which got replaced with Blu-rays. And at the same time, we had these other things, which were basically discs. They had like remember exactly which ones were which, but they had one which was called the Jazz, like could hold like 1,000 megabytes or something like that. Maybe it was 100 megabytes. I'd have to look. Um, and nowadays, those are just crazy small because we don't measure things in megabytes anymore. We've gone to gigabytes and even on to terabytes. So that has grown exponentially. Healing rates. That's an interesting one. I was looking for some of those this morning online to see if I could get some good values, but I didn't find any. Healing rates basically says that if you have a wound, which is 100 square centimeters, when it's that big, it's going to be healing faster than a wound which is 50 square centimeters would be. So it is a rate which depends on the size of something. Radioactive decay, I will describe my analogy for that, like dice or coins or something eventually. But radioactive decay happens exponentially. You lose a lot more of a radioactive substance when you have more of it. And various costs. I think one of my examples involves the cost of stamps and things like that. Okay, so let's jump in and let's use one of these equations. These equations all look like PERT, PE to the RT or PE to the KT if you want to use a K. Sometimes people insist on writing the equation for exponential decay as PE to the negative KT, but I just allow K to be a negative value itself, and then it's all the same equation. So PERT works, or PE to the KT. What that R is gets a little bit lost in the shuffle, and that's okay. In our first case, though, it is that 3%. So $10,000, which is my principal amount, $10,000 times E to the rate, and that is again 0.03, and my time the first time around is 5. So that is literally what I'm going to type into my calculator, unless I simplify things a little bit by multiplying the 0.03 by 5 myself. 10,000, and the E button again is right there on these guys. It automatically knows that you want to take E to some power, and I will say 0.03 times 5. And we get this 11618. That is 11618. And it looks like 34 cents. And all I need to do for 10 years is change that 5, that up button and the over button, all the way to where it was 5. I'm just going to change that to a 10. And I could either hit the insert button or just rewrite the parentheses at the end, which is what I did. And this time I've got 13,498 and 59. We move it around cents. Okay, so notice in those first 5 years, it gained about $1,618, and it gained more than that in that second 5 years because we were accumulating interest on that interest. Okay, that is basically it. I am going to write down some answers, maybe include those at the end of the video, or maybe I will just email them to you. Thank you.